Hello dear students, once again welcome you all for Power System Operation and Control class. In the previous classes, you have seen how a thermal unit is committed, that is unit commitment. And in the previous semesters, you have studied how a number of units are working togetherly, how to get the economic output from that one, that is called economic dispatch. These things are only for thermal units. If one hydel unit as well as a one thermal unit or number of hydel plants and number of thermal plants are used togetherly, it will increase the efficiency of the system, because hydroelectric plant can be started quickly as it has higher reliability and greater speed response. So it is useful to controlling the fluctuation of the loads. On the other hand, thermal plants start slowly and the response time is slow. So normally thermal plants are prepared as the base load plant, whereas the hydroelectric plant is run to peak loads. So in the hydel plants, the fixed charges will have to be taken into account even when there is no power generated. Therefore, a minimum overall cost is achieved by maximum exploitation of hydropower. Hydropower constitute approximately 20% of the total electricity production of the world. So, what are the advantages of a hydroelectric power system? We will see. What is the use of hydroelectric system? If you are going to use a hydro power, what are the benefits? The first one is it is a renewable energy source. Obviously, it is available freely in the environment. Next, it has immediate response to fluctuation in the load. As we have seen in the previous chapter, it is your thermal has got a slow response because of comparatively it has got a very high response to fluctuation in the load demands. It promotes guaranteed energy and price stability, as the raw material is not subject to any marketing fluctuations. This is one of the important thing here. You see, water rate cannot be differs because it's only purely dependent from the nature. Like your coal rate is depending on the international market, but it is not like that. Availability of water is the main thing. So it promotes the guaranteed energy with the guaranteed price. A reservoir performs the additional job of collecting water. If you are having reservoirs and dams, so you can store the water and it can be used. And since response is fast, it increases the stability of the reliability of the power system. Obviously, as the response time is fast, so it increases the reliability. Once it is reliability increases, means it gives the good stability to system. So it helps in the fight climate changes, because very low amount of GHG, that is greenhouse gases. So if you compare to a thermal plant which emits the more impurities and which makes the pollution to the environment, but compared to that it is very less, and it is sustainable, clean, cheap energy source. Sustainable, very clean and cheap availability of the water. So these are the some advantages of the hydroelectric system, and it has got some disadvantages also. One is high capital cost. We need to build a dam, reservoir. Its civil structure is very difficult compared to other. Then dependent upon the rain and monsoon. Oh yes, if rain is good, then only we can use the water. If there is no rain, no water in the reservoir, it's very difficult. Construction of the dam can cause the inundation of land and wildlife habitat. So there are many difficulties to build a dam. We need to take many permissions, and we should think of the earthquakes, and it will destroy the life. Sometimes many cities are undergone this dam, so it will affect the wildlife. So there will be restrictions from the ecology department also. So all these things will be there. Danger to aquatic life. Well, yeah, say it has got a highest danger to the aquatic life, and it can cause a displacement of the local population. As I told you, many cities are undergone this dam. You might have seen in our district, Uttarakhand district, there was a taluk called Supa. Supa was a city. When the dam was built there, the total Supa was undergone this dam. So now that taluk place is become Joida. There is not at all Supa is there till here now. So means total one taluk place, on taluk headquarters, was displaced because of the one dam construction. So we need to see this kind of disadvantages. So let us see the classification of the hydroplants. So we will see this figure. It just shows the hydroelectric plant. So this hydroelectric plant is consist of a water created by a dam. The system consists of a body of water created by a dam and the plant and an exit channel. So the energy available for the conversion of a function of the gross head and the water discharge. So gross head means the difference between the upper and the lower water level, and the discharge of the water is a function of the energy conversion. So most hydraulic plants are used reaction type turbines, Francis turbine, Kaplan turbines. You have studied these things. So with having efficiency of full gate loading is around 85 to 90% for low and medium heads. Impulse turbines are used for high heads. The efficiency is affected by the megawatt loading. At light loads, the efficiency drops around 70% also. At the full gate, it is around 87%. So to make the best use of the hydro plants, we need to operate it near the maximum efficiency point for which the required head is necessary. The water release schedules must be coordinated with the reservoir inflows to maintain a high head on the turbines permitted. So hydro plants are classified as based on the different parameters. Two parameters we need to see. One is classified on the basis of type. Another classification is based on the location. In the basis of type, it is classified as two types. One is conventional plants, another one is pumped storage plants. Conventional plant, once again, it has got two types. One is run-off river plants, which have a little storage capacity and use water as when it is available. Unutilized water is spilled, means how water flows in the river, that will be utilized. That is called as run-off river plants. Second one is storage plants has got reservoirs with the storage of the water when power required is low and release when the demand is high, means the there will be reservoirs. No, it will reserve the water when power required is very low, power demand is low, and it will be released when the demand is high. It will release the water. So another one is pumped storage plant. It has got two reservoirs. One is upper reservoir, another one is lower reservoir. During the light load, water from the lower reservoir is lifted to the upper reservoirs, and during the peak loads, water stored in the upper reservoir is released to the generate the power to save the cost of thermal plants. So this is regarding pumped storage plant. Another classification is based on the location. Based on the location, they are classified as the plants on different streams where the plants are connected to a common load but located on different streams are independent to each other. Second one is plants on the same streams where plants are located and downstreams and upstreams. Multi-chain hydro plants, which are combination of the above. So this is the classification based on the location. Let us see scheduling a hydro system. The power developed in a hydro system depends on the water head and the discharge, as we seen. The head is the vertical distance where the starting point is the water begins to impact the pressure on the turbine, and the ending point is where it ceases the exert pressure on the turbine. A low head height is of head of 10 meter and below, and a high head height is of head is above 20 meter. The hydraulic power is given by power pH is equal to head into flow into acceleration due to gravity. So if you consider a head in meters is h and acceleration is meter per second square, a 10 meter head and flow of 20 liters per second, the hydraulic power is given by pH is equal to 10, which is a 10 meter head into 20 liters per second is the flow, 9.81 is the gravity. We are going to get 1962 watts, 1962 watt is the power. So all the hydraulic power is not converted into electric energy. This is the hydraulic power what we have calculated. pH is for hydraulic power. So we have the we need to consider the efficiency of the turbine and generator. So around 50 to 60% of the system efficiency means hydro power total power, out of the total power 50 to 60% is converted as electric energy. From the above problem, we can tell out of 162 watts hydro power, it will be converted as 1178 watts of electrical power. So the power generated using idle plant PGH is given by eta rho QGH, where eta is the efficiency of the system, rho is the power density of the water in kg per meter cube, and Q is the water flow in meter cube per second, G is the acceleration due of gravity, H is the head in the meter. So which is PGH. So one problem is given here. You can see here the problem. Find the electric power generated by a plant with the head of 150 meter, rho of the water density is given by 1000 kg per meter cube, Q the water flow is given by 0.095 meter cube per second, and generator efficiency is 89% and turbine efficiency is 85%. If you put all the values, you will get 105.753 kilowatt, which is nothing but 141.76 HP of the power generated, electric power generated from the above given data. This is regarding a hydel plant. So next class we will see how the thermal and hydel plants are used together. Thank you.